Welcome to Shop Bench. Today we're going to have a go at putting together a DS1302 digital LED clock. It's one of these kits that I picked up on a momentary shopping spree on AliExpress, and it caught my eye because right now I don't really have a clock in my desk area. I really like something interesting to look at, not just a standard digital clock. And this particular clock is an LED based circular display with a numeric panel in the middle. We'll take a look at the actual clock itself. So here's the clock on AliExpress, and it's described as a rotating DS1302 digital LED display. It has an alarm clock and a number of different features. It also has a temperature sensor and a light dependent resistor on there too, so I'm not really sure what the LDR will do. Maybe that will control dimming, don't know, we'll find out. But I do know that the thermistor is used to measure some temperature, and we can see some of the features. It seems to be relatively full featured for just a little clock kit. You know, again, I just picked it up to work on those soldering skills and have something that I can look at, visual interest, and this fits the bill for two purposes. Looking through what it actually is, you know, we have a schematic here. You can see it's got the 7-segment display, multiplexed here. You can see this is where the power comes in from a USB style connector. This is where the temperature sensor is. We'll be reading this from an analog input. This is where the LDR is. We can see this is where the actual clock module itself is, the DS1302, just an 8-pin device. And then here is the brains of everything. Now this is it looks to be an 8051 based microcontroller, and this was the datasheet I can find. I can't really, obviously not able to read the whole thing, but the key pieces seem to be that it's an 8051 with 4K of SRAM. It seems to have pulse width modulation outputs, and then it also indicates that it has ADC inputs here. You can see it's got 10 ADC inputs. So as an 8051 processor, that's actually quite full featured. I've not played with any previously that had this much RAM. Typically, you know, you're talking 128 bytes, 256 bytes on some of the older styles. This really is quite a souped up 8051, really capable looking little chip, and it seems to come in a 28-pin package. So, you know, it's quite a few of the ports are implemented on it. Some of the click down 8051s only have 2 of the ports, port 0 and port 2. This one has port 1, most of port 2, a couple of pins on port 3 as well. So as 8051s go, quite capable. So looking at the kit itself, it comes in this fetching plastic bag, and we seem to have a USB power cable, bag of pieces. This is the actual board itself. The components go on the rear side, and then we have, you know, mostly the LEDs around the outside here with the thermistor and the LDR on the front. And then on the back you can see we have the 2 control buttons, a number of through-hole components, socket for the main MCU, it's mostly resistors, socket for the RTC itself, the USB header, and then a couple of capacitors. There's a buzzer and a transistor to drive the buzzer, and then this is for powering it with a 3-volt battery by the look of it, 3.3 volt CR2032 style battery. So opening the kit up a little bit. You can see it comes with some standoffs. Some of the photos I've seen online have it mounted. Oh, it's a little tight fit. There we go. There we go. The press buttons are they're quite tall type, actually, not what I was expecting. I was expecting to be a bit shorter, so these are much taller than I expected. USB connector, the transistor, larger value caps, smaller value caps here, then all of our LEDs. Now I looked around to try and find one with different coloured LEDs, and I wasn't finding one with the colours that I want to, so I'm actually going to be replacing the green LEDs with my own blue ones, and the red LEDs with some nice orange ones. So my version of this clock will be a blue and orange based, and hopefully there won't be too much of a difference in the forward voltage for these, so that the relative brightness compared to the green and the red should still be good enough. That's the hope. As usual, we'll put it together and we'll see how it looks when we get there. And it comes with a set of instructions. Shows you the actual board itself, and there's the chip number. They describe this as a Nixie light, where it's definitely just 7-segment display. It's got the usage instructions that were listed on the web listing. Doesn't really tell us much, although at least we can see on here it does have the values of the components. So the silk screen on the board calls out the components, but it wasn't calling out the actual value. So here we can see you've got the 470s. These are all the 470s are current limiting resistors for the pin, the microcontroller to sync current through the LEDs. All the pin lines. Looks like I've got a couple of decoupling capacitors, one here and one here, so that will be these two small ceramics. And then that one will be the larger electrolytic there. So it should be fairly straightforward, just a matter of putting the right pieces in the right slots. Oh, looks like we've got two more capacitors. Got some small ceramic disc caps right here. So C4 and C5, 10 picofarads. So we'll have to check when we get there. That one looks like the microfarads, and then the picos there. So with that in mind, we'll get started. Take this apart and just take a look at the relative heights of some of these components before we start soldering them in. I have a feeling resistors are going to go in first, and then we'll do the capacitors, probably the crystal. There's a watch crystal as part of this circuitry here, right there. That may be standing a little bit taller than some of the other components. And we'll probably do the sockets, the battery compartment, USB, and then probably the buzzer last. I think that will be the tallest. Yes, get this apart. Packaged relatively well. Certainly survived the trip unscathed. There's our temperature thermistor. So we'll have to make sure that we get the 7-segment display the right way around when we get that far. Let's take a look. What do we have here? Looking for the 470s. Looks like these guys. Just to be sure, I think we'll just quickly measure them because it's super difficult to read the colour scheme on these metal film resistors, these blue ones. I mean, they're small enough to begin with. Let's see if we can put that here. See what we're looking at. So those are 20K. And those are the 470s. Let's just quickly check the schematic to see if there's more than the two values. I think that's the two values that we have. 20K, 20K, 470, 470, 20K. Yep. Alright. Well, we'll start with the 470s because these are all in a nice row right there. We'll just snip these off the end so we can save ourselves having to wipe off any sticky. There we go. Let's just zoom in a little bit. Alright, so we've got R1 through R5 here are all 470. It's not very neat. Try that again. I'm not sure I'll need this last one because I haven't counted that many, but these 3 here, 3 there. I'll just double check the instructions in a minute, see if we can spot another 470 anywhere. Here we go. So it's a nice fresh piece of solder. Alright, it's the first lot of resistors in place. Just trim these up. Sticking up still a little bit higher than I'd like there. There we go. A bit more flush. It's better. That's better. Alright, so from the diagram you can see we've just done this bunch of 470s. The two 470s there, and this one 470 there. And I'm just taking a quick look around the diagram to see if there is an extra 470, and I do not see one, so I think this is a spare, be an extra. Now we've got 1, 2, 3, 4, 5, 6, 20k. And again, looks like we have 7, so they give us a spare one. Now these resistors, the legs are so thin on them, they're really quite bendable. I've only recently just started doing electronics again from previously, and I much prefer the carbon film resistor colorations and thickness in the leads than these metal film ones, but obviously the accuracy of the metal films is better. The stability is, I should say, and the tolerance is certainly a bit better. These are 1% resistors typically, I think a lot of my carbon film are maybe 5%. Usually not critical, but it's good to have that extra degree of precision if your circuit needs it. not bore you to tears with soldering every single LED in, because it's going to be hard enough doing it myself, let alone watching it. So you may find the wheels of time turning significantly quicker for you than it does for me. Getting the measure of the width of these holes for the leg bending. A bit neater than when I started at the beginning. Come on, you can get there. Get in there. There we go. I was being impeded. Prior to starting filming this little project, I actually did a little bit of an ad hoc project and added some above desk lighting, so it should be a little bit brighter than the last two. So if there's any difference on the video quality, for better or for worse, please feel free to let me know. So far it's looking better as I'm recording, but can't really tell. We got 1, 2, 3, 4, 5, 6. Here's our spur number 7. Let's pop this over. Resistors round 2. I've only just recently started using this more chisel tip. Up until this point I was using more of the conical tip on the soldering iron, and first you think, oh, it's a lot bigger and fatter. How's that gonna get in there and do the same job that I'm doing with the more fine pointed conical tip? And it's doing just fine. And obviously with the larger tip volume, I'm getting better heat transfer. I'm definitely noticing that. Now, I'm seeing a little bit of solder creep up the lead like though as I'm soldering this in, but and I'm going to be snipping that down, so it's not really that much of an issue. I'm watching for solder build up on the tip a little bit more, which I wasn't experiencing as much with the conical tip. Normally if I wasn't filming I'd be spinning the board around, and this would be a little bit easy to come in from this right hand side against the bent leg, but I just don't want to wave my hands around all over the desk and start flapping everything around. So just learning to solder in a non-optimal orientation. At least it's not left-handed, that would be terrible. Alright, that's all the resistors done. So looking at our components height wise now, I think it's time for these capacitors, these ceramics. Not yet for their electrolytic. Those two bits are on the front, these are on the back. Okay. So 10 pico, 10 pico. I'm going to go in C4 and C5. These should be the loading capacitors for the watch crystal. I think we'll go ahead and thread watch crystal into. Now this one's a little bit tricky because we're going to want to bend it over but not flush to the board at the base. I'm going to want to have it slightly higher, there we go, like that. Again with these super fragile thin legs. I'm soldering the watch crystal. I'm going to try and be a little bit quick on the heat application, maybe wait a little bit between each leg because I do not want to damage the crystal by overheating the component. So we'll do that one leg first there, and then we'll go do these capacitors, give that a chance to cool down just a little. Circle back and do the second leg there. I don't know if for some reason turns out that I've damaged the watch crystal. I think I do have some spare watch crystals. Yeah, I see it barely got hot, so I'm feeling pretty good about that one. Or that cap's a bit wonky. I think we'll live with it though. Do I want to live with it? No. I'll straighten it up a little bit. It's a bit neater. Snip these bits off without losing an eye. There we go. Lovely. Okay, yeah, I still think they were the shortest profile pieces. I don't think these ones are next, so we're looking at how we're going to be doing C3 and C2, the 0.1 micro. These appear to be, from the location, look like they should be decoupling capacitors for the chips. Let's pop them in. I know there's two schools of thought on whether they should bend over the pins or not. Bending them can technically stress the components, and maybe you don't need to, maybe you do. I find it a little bit easier to bend them if I'm putting in multiple components ready to flip the board over. It just makes it a little bit easier, and then it tends to hold them a bit better against the board, so not quite as wonky, but perfectly doable, perfectly possible without bending them over. I will be avoiding bending the pins on the LEDs because as on previous projects I have learned that if I need to take the LED out, this bent pins approach, the issue you have is if you want to desolder them, that slight bend as it comes through the through hole is enough that if you heat up the solder to try and push it through, the bend is holding them in place. You know, the very reason why we bend them in the first place, to hold them in place. Unsurprisingly, holds them in place. I'm feeling like these components are unlikely to have a failure and need to be pulled out and replaced, whereas these LEDs could well have one or two busted ones that will need replacing individually. So when I put these guys in and solder these guys, I am not going to bend the pins. Alright, what we're looking at now, so I would say that's pretty tall. Probably on the USB, but this USB, and this is interesting because that looks like, for all the world, like it's going to stand upright. Very interesting. It's not one that's at an angle. Okay, we'll wait for that one. See, honestly, yeah, it's probably going to be the pin sockets. Let's line up these pin sockets so the notch is lined up on the silk screen. Here and here. That was relatively painless. Alright, so I'm going to try and just tack solder in a corner so then I can lie this flat, because there's not enough of the pin legs coming through to be able to bend them in any meaningful way and hold it in place. Let's do this one at a time. Do the small one first. There we go. Just need enough to get this one corner in there. So now I can hold it on the bottom, push it flush, refloor that. Again, what we can do is just put a bit of solder on this bottom corner, and again I'll push it through from the bottom, reflow it flush. Looks pretty good for the two corners. Pop this one in place and then we'll just whip through and do all the legs for both of them. Perfect, that's both of them. Let's see if we can just whip through all these pins. Solder. small socket here. They're actually not sticking up that far. I don't think I'll bother snipping those right now. It's fine. Alright, both sockets done. I think this electrolytic will be shorter, so we need to get the negative stripe indicates here the short leg with a negative indicator, the stripe on the capacitor. Let's put this in the correct way. So this one's polarized compared to the other two. The other four, I should say, there are two types, ceramic and non-polarized, so no way to mess those two up. Just wetted that pad properly. Done. That's still going to be taller than this. The buttons are going to be taller than that, so pretty close. I'll do this battery holder. God, soldering iron's making a bit of a buzzing noise. Didn't notice until this minute. Flush. Flush. Looks good. Right. Transistor. Now, this has got the offset leg space. Now, obviously they're in line on the actual device itself, but on the board it's offset. So you want to get this little pin out just a little bit. Help us out. There we go. So let's get that in. I'm not going to bend the pins on this because I don't want to put a lot of mechanical strain on the transistor housing. They're not the most, I mean they are robust, but then they're not the most robust piece, not like a resistor. A little bit. There we go. It's a bit neater. So the transistor is used here to drive the buzzer, because it will want more current than the pin of the microcontroller alone will want to supply. It's being used as an electronic switch to switch a higher current. Just taking a look at this P1 header. I actually don't see any header pins anywhere, so maybe they are not necessary. Not sure at this point. We'll see. Not sure what exactly we'd use them for. Maybe they're just test pinpoints. Now, on the buzzer, I'm not sure if this is going to show up super well. See if we can bring this into. It's not going to focus. Up on the buzzer, it's actually polarized, so you can see. Maybe you'll be able to see a little bit there. There's a plus sign here, and then on the board there is a plus sign there, so I want to make sure we get this oriented the right way around. It's been a little bit tricky, pens are splayed just a little bit. There we go, plus to plus. That's that one in. Super happy with that joint there. That's better. That's wet the pad better. Did not have the nice shape of a good clean solder joint on it on that first one. I don't want that to be non-functional. Alright, so now what we've got left is USB and the 2 buttons. Still think the buttons are taller, so USB, here we go. Press them down. A little bit more difficult to solder because the whole thing itself is essentially one giant piece of metal and wicking away the heat from the soldering iron. You can't quite see this, but the feet are only just protruding over the hole there. Unfortunately, it's only supplying power, not necessarily any kind of data signal, so as long as the power pins of a good joint, we will be okay. We'll very quickly find out though. I'm trying to power it up. Boom. Now the legs on these are a bit thicker, so I have to be careful with the snippers and snip slowly, apply the pressure slower when the pins are thicker to avoid damaging the snips, because even though they can mechanically get through it, if you push too hard, I have definitely damaged a couple of clippers trying to snip too aggressively something that it can actually cut through. Alright, it's the USB. Let's get our buttons. Now the thing about these buttons is it they look like they're a square footprint, but they're actually slightly rectangular. So you can tell which way the button is supposed to go in, because it will only orient along that rectangle properly. So if you find yourself trying to bend the pins in an awkward way to cooperate, the odds are the button orientation is incorrect. There we go. Nice positive feel on those, I like those. Nice tactile switches. Do the same thing, we'll just tack in a corner on each, then press and hold the board from the other side, and make sure our component is aligned on the board nicely. There we go. Just make sure it's nice and flush with the PCB. Yeah, those look nice. Let's get this remaining legs done. Functional. These down. Alright, not too bad, not too bad. Making good progress. It always takes a little bit longer than you would like. That's everything. Other than this header, I'll have to see. I didn't notice any headers in the pictures. I can't see a reason to need it. If you're powering from here or here, it would have to just be some kind of test pins or alternate power. It's not labelled on the diagram what, if anything, it goes to, so we would have to take a look at the schematic. Why don't we just take a look at the schematic? So it looks like that header is an alternate power and ground, and then P1331. Well, they may attach to anything. Oh no, P1331. So 3.0, 3.1, typically they are serial. Oh yeah, there we go, communication. So this will be a serial communication, so this must be spitting something out through UART. Interesting. I did not have a header in my kit though, unless I am totally overlooking it. But, I don't see one. Well, I have some header pins, so it's not really going to be an issue. So I think at this point LEDs are less tall than this. Let's have a look. Yes, so we're at the point where I'm going to be soldering in all of these LEDs, the thermistor and the light dependent resistor. I'll go ahead, I'll put the thermistor and the LDR in, and then I will spare you the agonizing experience of watching me solder in a million LEDs. Believe me, if I could skip forward myself and just haven't done, I might well entertain the idea. Pop this LDR in. It's not polarized. And then the thermistor. Now, with something that has like an envelope like this. This is kind of like a glass envelope. It's generally preferred to use something like a pair of pliers to bend here, because if you mechanically apply the pressure yourself, it actually transfers the stress all the way up to the interface between the LDR here. I've just formed the legs here. It was totally off screen. Rather than bending this leg down, because this is a glass package, I used the pliers to bend the legs down, and that relieved stress here, so hopefully we haven't caused any mechanical stress on this piece, so it should be in as good a working order as when it arrived. And then I do not know if that is a heat sensitive component or not, so I will be cautious and do one leg, the LDR, and then go back to the other leg just to be on the safe side. That's the one leg there, so I'm going to pop over here to the LDR. Back to the thermistor. The pad wasn't wet very well. That's better. That's better. There we go. Okay. So at this point I'm now going to put the LEDs in. So the thing to note about this is that obviously LEDs are polarized. They have marked on the silk screen positive and negative. Positive seems to be along the outside edge, negative's all on the inside edge. From an LED, the long leg is positive, so it will be going in this orientation, and then you have obviously uneven numbers of LEDs. The red LEDs will be signifying hours, and the green LEDs signifying minutes. So we have hour, then 1, 2, 3, 4, and then another hour. So the hours are going to be on the numerals. Should be 12 of them, and then the filling in between should be the rest. So 4 times 12, 24, 48. Should be 48 of these. I'll be replacing these with 12 orange and 48 blue. I will be back when that is finished. Welcome back. As you can see, I went ahead and finished the build. That was just soldering in all of the LEDs. Put the 7-segment display in, screwed in the standoffs, and then I did go ahead and find a 4-pin header to attach for the communication. We'll see if anything actually does come out of that at some other time. And now for the moment of truth. Let's see what it looks like. So we've got the power USB here. Alright, I'll just go ahead and plug this in here. Alright, there we go. Just check if all the LEDs work. Seems to be ticking around. Oh, yep, there we can see the temperatures being displayed. Let's see if we can influence that temperature a little bit. Just warm up that thermistor. See if next time it cycles through we have an increase in temperature. It was about 26, 27 before. Yep, there you go, it's up to 30. So it looks like it cycles through the current time, the temperature, and then the date, the year, and then the month, and then I'm not sure what that indicates with the number that followed. Yeah, it seems to be, all the LEDs seem to be working. So it looks like the hour indicators are permanently lit, and the minute just ticks round, so you can always see the hour and the minute. Let's see what the, not sure what the LDR does. It doesn't seem to do anything. I'm holding my hand over, I don't see any perceived change in brightness. You can see flicker on the screen. It's multiplexing the LEDs and the 7-segment display, but you can't see that in person. Wherever the refresh rate is there, it is below normal human perception. I don't notice any flickering at all. So I guess all I really need to do now is look at the manual, see how I set the time, and set the date. And then this is obviously a real-time clock backup battery. So I'll pop a battery in there, set the time and date, and then use it. So the only pieces of advice I would give on the bits that I didn't show on the build is when you're soldering in the LEDs, I started by doing all of the orange ones first, and that gives you plenty of space on the back to work, to get the soldering iron in and not collide with any pins between the LEDs. So I soldered in those and then snipped the pins flush, and then I went ahead and did the next one, the first blue one, butting up to the orange ones. Soldered it in, snipped the pins until I did them all, and I didn't have any issues soldering the pins in. It wasn't quite as cramped as when I did the hourglass build, where I did not space out the LEDs. It was definitely a little bit easier to get into the legs and solder them, and it went pretty quickly. So definitely recommend doing that. And then I think if I were to look at this again, if you notice, the buttons are just taller than the standoffs, so I'm either going to have to put some longer standoffs, and the USB port obviously is a bit taller than the standoff, so I'm not really sure what we would do with the standoffs. If you had like a right angle USB cord, so it hung down rather than out, and then maybe double the length on the standoffs, that would be a bit more useful. I think maybe I would consider actually putting the buttons on the front side, and then not necessarily using the really long ones. I would maybe use the short ones. Sorry, we're in a different mode. That must be the mode switch. That's asking to set something. Oh yeah, there we go. That's how we cycle through. So we've got plus and mode. If you press them both, it looks like it cycles through the how it illuminates. Oh, so now this time it's turning an LED out. So holding mode and pressing plus. Oh, that's almost like a waterfall effect. A nice randomized display. I like that one. Oh, that one's nice. Kind of like how that flows down like that. That's pretty good. Oh, it's whatever, it'll fill up from the bottom, almost like an hourglass. That's pretty cool. I like that one. Oh, that one's pretty good. You wouldn't miss that one. It is quite full featured on its displays. Not bad considering it's just a 8051 microcontroller doing that, but the software in this is quite sophisticated really for such a simple build. You know, it's the kit itself is about $7.50, which is on the higher side of some of the pieces that I buy when I'm on my shopping sprees. But yeah, definitely like it. Definitely like this clock. This is great. I could definitely recommend picking one up just for the experience of putting it together, and then I think I will enjoy having it on my desk. Yeah, I really like that. Definitely recommend it. So yeah, if you're thinking of picking one up, you'll have a couple of hours of fun soldering, get those skills sharpened a bit, and have a really nice product at the end of it. So until next time, have a good one.